Hey, welcome back. This video is our first in a series of videos on plotting in Python. So we've actually made a few plots in this class already. We've used the Matplotlib package for data visualization. We haven't really talked too much about how it works. And so this is our moment in the class where we're really going to get into the internals and create high quality data visualizations by making good design choices, labeling our axes, like all the good plotting stuff. So Matplotlib is really our second big tool for computational and data science in Python. And by design, it works fantastically well with NumPy. So throughout the remainder of this course, we're going to be pairing these two tools together. Okay, so in this course, we're really going to be focusing on matplotlib.pyplot. So that's a module within Matplotlib. So let's get our two core libraries. So the first of these is NumPy, and the second is the pyplot module, and we'll give it a name. So we'll say from matplotlib import pyplot as plot, PLT. Okay, so now we have both of our libraries loaded in. So in order to get fine-grained control over our data visualizations, I want to really get us used to using the object-oriented interface to Matplotlib. And that means getting careful control over our figure and our axes, okay? So what is that? Here's a diagram. So in this diagram, I have one figure. The figure is the overall visualization. And then within my figure, I have four axes. So you can think of an axis, for example, as a pair of XY coordinates. And so an axis is a little rectangle given by XY coordinates here. And I have four distinct axes. So I could, for example, plot four functions without having them overlap or conflict with each other. They would each be on a different axis, but they'd be within the same figure. Okay, so let's kind of see this in action. Our basic workflow when we are using Matplotlib in this way is to create a figure, then add one or more axes. Then we're going to add data markers to the axes. And the data markers are what we often really think of as the plot. It's the thing that you draw that actually represents the thing that you want to represent. Then, as our fourth step, we should add annotation such as axis labels or titles or ticks or legends, anything else that someone needs to understand what our plot is about. And then finally, save the figure so that we can show all our friends and take it to parties. Okay, so unless you need something very customized, it's actually easy to do steps 1 and 2 simultaneously using the plt.subplots command. So that's what I'm going to teach you here. So what I do is I'm going to create a figure and an axis simultaneously using plt.subplots. And what plt.subplots does is it's going to create a figure with a number of axes that I specify. Here I've said, hey, I want a figure with one row of axes and one column of axes. So I have a 1x1 grid, so just one axis. So if we run this code, we'll actually, Python will show us our figure. So here it is, super exciting. There's nothing much on it because we haven't put any data markers. So right now it's just a blank white rectangle. Now, one thing that I want to note, because this is going to be a little different shortly, is that when I have just one axis that I create with plot.subplots, the axis refers to, or the ax, the object that I created, refers to the axis directly. So you see here when I query what ax is, I see that it's a matplotlib.axes.subplots.axes subplot, et cetera, et cetera. That's just a way of saying that this is really an axis. It has the axis methods that I'm going to need later. By way of contrast, let's actually make a plot with multiple axes. So here's fig and ax equals plot.subplots. And I'm going to have one row and two columns. So now there are going to be two axes. And I want to make them look a little nice. And I happen to know what aspect ratio is going to make them look okay. So here I'm going to change the fig size. So that's the size of the figure. It gives me the dimensions. Okay, so here, now I have a figure with two axes. So one figure, two axes, and here's now an opportunity to plot on two separate axes to my heart's desire. Okay, Of course, we can also make more fancier things. So we already saw that 2x2 grid. Let's recreate that. So fig ax equals plot.subplots to 2. So here now we have a 2x2 grid. Okay, so in the case when we only had one axis, the ax object that I created actually referred to the axis specifically. But let's take a moment to notice what kind of an object we create when we have multiple plots. So recall that I have this 2x2 grid of axes here. Let's take a look. Well, hey, check this out. The object that I've created is a NumPy array. Okay, so we know NumPy arrays. This is great news. So the axis object that I've created here, it's 4 axis objects, but they're organized in a NumPy array. Each element of this NumPy array is an axis object. And of course, the NumPy array itself, so we can check its shape. And we see, oh yeah, it's a 2x2 NumPy array. So this makes sense, 2x2 grid of axes represented as a NumPy array. This means that we can access the axes using NumPy indexing. So for example, if I want the axis that's in the first row and the second column, I can do ax and check for the entry at coordinates 0 and 1 and say, okay, yeah, there is an axis there. So I can actually query the axes in the same way that I would query any other NumPy array. So far we know how to make grids of empty white rectangles of various shapes and sizes, and that's super fun. You can already take that to parties, but let's add some data markings. Okay, so to add some data markings, we need some data. We need an intelligent choice about how to visualize that data. Do we want lines? Do we want dots? And then we also need one or more axes on which to put the data. So let's make the axes first. So fig ax equals plot.subplots. I'm going to do two subplots here. So let's make them just a little bit bigger so that we can see nicely. Let's do 7 by 3, say. Okay, so here's our 2 blank axes, and we are now ready to put something on them. Let's make something that we are going to put on them. So I'm going to make a horizontal coordinate. Let's see, I'm just going to do 21 evenly spaced points between 0 and 2 pi. And let's do, for the first vertical, I'll do just the sign of x. And then I want to put something on the other axis as well. So let's do np.log of x, say. Okay, so if I run this code now, I'll get a warning, and we'll see why in a moment. But okay, so what I have now is I have several different NumPy arrays, and I'm ready to plot them. So let's do it. So remember that I have a 1x2 NumPy array, so I can query it in standard ways. So I can do what's in the 0th row in the first column. Oh, sorry, I have, sorry, it's a 1-dimensional array now, so I have just the 0th element, so it only has 1 dimension. That's the column you're in. So I have a single axis, axis 0, that's the first axis, if you will. And let's do a scatter plot. So the scatter is a method of the axis. I tell the axis, hey, scatter the points over yourself. So I can scatter x and y. And then when I run this code, nothing actually happens or nothing is shown when I run this code. I need to actually ask Python to show me the whole figure just by asking it to show me the fig object again. Okay, and when I do this, I see, okay, well, there's my first scatter plot. I have a plot that looks like the sinusoid function. Pretty nice. Okay. So let's keep going. Let's put something else on the right axis. So that's axis 1. Okay, so ax1. Let's do a line plot this time. So the method for line plot is just ax.plot. So let's plot x and z, and let's give it a label this time. You'll see why we give a label in a moment. Label hashtag best logarithm. Okay, so let's plot that and then run fig again. Okay, so now we see the figure again, and we observe that we've been able to add a line chart, or just a curve, to the axis on the right-hand side. So we have dots on the left axis, a line on the right axis. Pretty good so far. Now, we don't have to stop here. You can put more than one set of data markers on an axis. So for example, suppose that I want to add dots as well on the right-hand side. So I can do ax1.scatter x and z. That'll give me dots on the right-hand side. And they just get plotted over the curve. So now I have dots that are joined together by a curve. Okay, lovely. So those were our major steps. We needed to create a figure. We needed to create one or more axes. And then we needed to put data markers on our axes. However, we're not done because no one really knows what this plot is. And for that, we need to give annotations. So annotations are tremendously important in responsible data visualization. Give your plot a title. Give your plot axis labels. Give your subplots titles, like really label your plots. Okay, so let's see how to do this. So there are axis.set methods, and these set methods will let you add annotations to individual axes. So for example, let's add some annotations to the first axis. So x0.set, and then the arguments of the set command tell me what kinds of annotations I'm going to add. So let's add an x label. And we'll just call it X. Let's add a Y label, and we'll call it Y. And let's give it an axis title, and we'll call it plot1. Not a great title, but you know it works. Okay, and then if I check Fig now, I'll see, okay, well, now my first plot has an X-axis label, it has a Y-axis label, and it has an individual title. Looking good. Let's add some annotations to the other axis as well. So let's set the X label equal to X. Let's set the title equal to plot2. And maybe we'll say, okay, well, because they share a column, they can share the same Y label. This is a common choice in scientific publications, for example. So here we have a mostly completely annotated figure, but maybe we should give an overall title as well. So to give an overall title, we actually have to use the fig object because this is about the whole figure, not about any individual axes. So we can do fig.suptitle, super title, I'm not completely sure, sup title. And then we call it my awesome plots. And if we do this now, we see, okay, great. I have an X-axis label. I have a Y-axis label. I have individual titles for my subplots. I have an overall title that tells me the big picture. I am ready to go. Okay, one more kind of important annotation is legends. Okay, so when we have multiple different series on the same axis, legends are extremely important. So let's take a look at this. I'm going to add some more data to my plots here. So I'm going to do x0, so that's my leftward axis, .scatter x, and I'm going to add the cosine now, rather than just the sine. Then I'm going to add to my other one, my rightward axis, I'm going to add a scatter plot, and I'm going to just do, let's say, the exponential of x over 3, and I'm going to give that a label 2. Hashtag best exponential. Okay, and let's see what happens now. Okay, so notice what's going on is that Matplotlib is actually giving different colors automatically each time I plot something. So it's automatically helping me distinguish between the different things that I have plotted using colors as a visual cue. So this is handy, but it doesn't quite get me all the way there because I'd like to know, hey, what are the blue markers? What are the orange markers? What does any of this mean? What are these series supposed to represent? And that's where these labels come in. So I sprinkled 2 labels into plot number 2. So each of those series has a label associated with it. We can see here that the labels don't really appear on the plot in any way. And the way that we change that is by adding a legend to the axis. So I can do ax1.legend. So I add a legend to the axis. Python will automatically try to find the best place for it where there's not a lot of data overlap. And here we see now, Python has given me a legend. You recall that I added that hashtag best logarithm to the curve. I added best exponential to the dots. So Python is giving me a little legend to say, hey, here's what these data markers mean. Here's a little label so you can tell them apart. If you have multiple data series on a single axis, you need a legend. So label your data series and get those legends on your axes. Okay, so now we're able to create simple plots. We're able to annotate them elegantly and thoroughly. Once we have a good plot that we like, we need to save it. So this is fortunately really simple. We can just do the savefig method of the fig. So we do fig.savefig, and then you just need to tell Python what file extension you'd like to save as, and then you also need to give it a file name. So let's save it as myawesomeplot.png. So this says, hey, I want this to be saved as a .png file with the name myawesomeplot. And if you save that, then you will later find myawesomeplot.png in your working directory. Okay, so we can now create simple plots, annotate them, and save them. In the next couple of videos, we're going to look at two-dimensional plotting and statistical graphics, so slightly more advanced material in Matplotlib that will really expand our visualization toolbox.